All right, guys, welcome back. It is time for part 2 of the Nexus S1 repair. This is just a reminder, this is the one that we ordered all these little caps up. The customers requested that I change the 4 V-regs out, which I'll do. So we'll replace all of these caps. We'll change the V-regs. He also mailed to me his heatsink and his display on a separate repair. But something I wanted to show you guys I thought was interesting is I have another Nexus S1. I've actually got 3 in the shop right now. And this one has a very similar problem. Same thing, we're losing those caps on the input side of the CSDs, which I thought was really interesting. This one's also got a cracked chip. So this customer fortunately is within his RMA window and has reached out to the vendor, and they're going to be RMAing that. So that's good news for him. So we'll be getting that back over to him ASAP. But I wanted to share that with you guys because I've told you in the past that many of the 1373 miners that we get in have cracked ASICs. And this one, fortunately, did not. This is the one that we're going to be fixing today. So we're going to go ahead and start working on this and getting this thing fixed. And I'm going to bring you guys along for the ride. And hopefully by the end of this, we have a good working miner. So I'll walk you through my process and how I do this. The first thing I'm going to do is I'm going to put some Capcon tape, which is a thermal tape, to help protect the components that are near this area. Now it's not gonna completely save everything, and if you're not careful, it will still melt stuff. Things are still gonna happen. We do have to get a lot of heat into this board for this repair, but this may limit the amount of other items that we're gonna have to replace. Like, I expect that we are probably going to end up having to do at least one fan header. I'm hoping not to have to do display headers, but we will cross that bridge when we get there. So the first thing I'm going to do is I'm going to set this Capcon tape up, and I'm going to try and do it in a manner where we roll that bottom edge like that. And what I don't want to happen is have this get in my way. But I want to try and protect as much of the plastic items that can't tolerate the heat as possible. I'm going to put a piece over here too. This tape works pretty good. It doesn't completely, again, like I said, it won't completely prevent, things from melting if you're close enough or you blast it directly. But it does protect it from the irradiant heat pretty well for the most part. You'll see, you guys have seen me do V-regs in the past on other videos, and I use a metal shield right here. It's just a piece of stainless that I have bent around in a certain manner to tuck around to help prevent the melting of some of these. But I have display headers, I have fan headers. If I have to replace them, I'll replace them. Just adds a lot more time to the job. All right. So I'm going to get my board heater out. And get our microscope squared up here. Give you guys a little better view. All right, so I'm going to kick this thing on. I'm going to change my tip and reduce my airflow in this tight space. I'm trying to do everything I can to not melt the surrounding components. I'm going to put a small tip on. All these tools, all these supplies, for the most part, we have listed in the description. They are affiliate links to Amazon, because for the most part, Amazon is where we get a lot of our tooling and stuff like that, because it's got the pretty good selection. When you got a Prime membership, you can save on shipping, which works out pretty well. Anyways, they're affiliate links. It doesn't cost you anything more, but we definitely appreciate it if you click on those affiliate links. When you do your shopping, it just helps us. We get a percentage of the sales a commission back. It helps the shop. It helps us continue to make these videos. And it doesn't cost you anything. It doesn't add anything to your price. So again, if you click them, we definitely appreciate it. So we're going to let this board warm up, get up to temperature, and then we're going to come back at it. All right, we're back. Board is warmed up. I'm going to turn this. See what the right angle I want to get on this is going to be. I'll probably leave it here like this. Yeah. All right, so I've got my airflow turned to 450, 35% airflow. So 450 on the temp, 35% on the airflow. I'm gonna come in here. I'm actually gonna drop that down a little bit more. Let's go to 30% airflow. Like I said, I got the small tip on. And what I wanna do, I wanna focus some of that heat. I'm trying not to melt anything here, but I wanna try and focus that heat away from the plastics. But get enough heat in this board where I can pull these caps off. You can see that Capcom tape moving a little bit. Okay, so I'm changing all of these. I'm hoping these bird ones come off easy. Try and not melt anything. Slowly but surely we're getting them. I don't want to take the little ones off. Awesome. That took a hit pretty good. My blue, I don't know if that's gonna clean up. Heat that board up real quick. Sweet, awesome. All right, now let's pull the V-regs real quick while we're here. Looks like that temperature sensor got bumped. Let's fix that real quick. Okay, good. Yeah, I think for the most part, we're in pretty good shape on our plastics. We'll know more when we're done. Okay, now I'm going to come in with some lower melting point lead-free solder paste. Make it so you guys can see it. I'm just going to dab all of these. Turn my soldering iron on while we're doing this. I'll get the caps done first and then we'll go after the V-rigs. Okay, now I'm going to come in with my soldering iron. You're going to melt these down on the pads. And we're going to go through and touch up every one of these. That solder paste has got flux in it. And what I'm trying to do is make sure I get all these metal particles, all these little solder particles, onto the balls, onto the pads, so that I don't want to create any shorts. And I want all that solder paste used on the pads. All right, those all look good. Now we have our new capacitors. I got the highest temperature rating caps at the proper value that I could get. The problem with this size is you can only go so high in temp. And at least for this particular capacitor. And we will start putting them on one at a time. Yeah, I figured it was going to do that. I figured it was going to cool it down enough to make it not want to set up, but that's okay. We'll put the 3 on. And then we'll hit it with hot air and get it to seat. Come on. not going to keep fighting that. We can just do it that way too. Excuse me. Keep working our way down. Couple more. So how many more do I need? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. 6 more. Excuse me. I'm going to come back in with some flux. And I'm going to hit all of these with just a little bit of air gas. I want to get these, make sure they're nice and on there. And I know this is probably not necessary, but it's just something that I do just to try and make sure that we've got good contact, good solder joints. Let's turn the air filtration on. Nobody wants to breathe this shit. I'll show you that. Okay, I'm satisfied with that. All right, now let's go and focus on the V-regs. So like you guys have seen me do before, same situation here. Got 4 new ones. Let's turn it around the right way. Dot to dot. Come on. Get that squared up here in a second. Okay, now we're going to go through and we're going to get these all seated. This is going to help to center them up and melt the center pad. There it goes. See it square up. Okay, that looks good. I'm going to give this one a little bit of help. There it goes. All right, let's take a quick look. I do want to take a quick look at that temp sensor. Make sure we don't have bridge pads. Excuse me. So all the caps look good, the V-regs look good. I have to clean up all the contact points on the V-regs, which I'm going to do here in a second. I have all my other little components in the neighboring area are all still aligned, still where they need to be. But I do want to touch up the temp sensor. That's what that is. Points, because it looks like that got bumped while we were getting that V-reg off. And it looks like those two legs have a slight bridge, so we're going to clean that up. There we go. That looks good. Okay. Typically, if you have bridges there, you have a situation where the display won't power up at all. So just something to be aware of. If you do this kind of work. All right. So now let's go through and work through all the V-regs. And then what we'll do is we'll check the board for shorts. Like I said before, I use a lot of flux, and I don't care. Flux is cheap. And it helps us get good solder joints. All right. When I do this, my board heater is still on 400. So I've got a nice heat soak in the board. Otherwise, this would be really difficult to do, especially here because these are really thick power traces. I'm not saying it can't be done. I'm just saying this is the way I do it, and it works well. look at it from this angle. Awesome. No obvious bridging. Everything looks pretty good. Again, I'll check the connectors, I'm sure. I definitely see some things that took some heat, but we'll deal with that after we validate that things are working. Okay. I'm going to turn that off, the board heater off. I like to do is let that cool for just a couple, 30 seconds, and then I come in and start waking up the flux. With Q-tips. Flux cleans a lot better, a lot easier when it's hot. And I know it sucks, and I know that a lot of people are going to say, oh, you used too much and you just added more work to yourself. Probably. But it's the way I do it. And I don't mind spending the extra time to make sure it's right and clean for the customer. It's just the way I do it. I know there's other people out there that can do it with less, and that's great. Let's let those set up first, and I'll just clean it when it's cooler. Sweet. All right, so let's let this cool, and then I'm gonna check it for shorts, clean it up, and if we don't have anything, then we should be able to start testing it. So let's let this thing cool off, and then I'll be back. All right, so I've got it cleaned up, taking a close look at things. Everything looks to be pretty good, pretty aligned. I don't see any obvious bridging anywhere on the control pins for the VREGs, for the CSDs here. Everything looks really good. I mean, we got some melting, and I'll take care of that, but we want to get this thing into a testing mode here first. So, and I still got a lot more cleanup to do, not a big deal. But let's check the continuity between positive and negative. I'll put our fuse back in here. And I'm looking for a high resistance, and we do. 3, 4, 5 K ohms and climbing. So that looks good. That looks really good. Let's get, turn that off. Let's get a heat sink on here. Customer did send his display in. Let's get a heat sink on here while we're doing that. Let me plug this in so I can get that set up. Again, I always put my heat sinks face down, and then I bring my board to the heat sink. The heat sink's really heavy, so then I put the board on level. Ooh. And I throw my Allen wrench, apparently. We'll run this down. Again, when I do my heat sinks, I do just finger tight at first. Then I check the depth. I look at the screws, the protrusion through the brackets, and I'm looking for a nice level. Nice even length on the protrusion. And again, I'm just using my fingertips to tighten these up. I don't want to overflex the board. I'll plug the fan header in. And save the customer's display, and I'm going to take my Nexus display because this is already configured. We're going to drop that in. All right, now let's send power to it and see what she does. And she is powering on. Let's see if she minds. And she's hashing. See if she gets up to speed here. I'm going to pull out the thermal camera. I'm going to check that we have all 4 VREGs running. And we do. it's looking good. We have all 4 V-regs firing up. That's a good sign. We're gonna let this thing hash. Yep, each chip's doing just over 2 terahash. This thing's set in the default. We have relatively good nonce distribution. You can filter that in the logs. You can look up hash rates, or you can look up nonce. If you type in nonce, it'll show you the distribution. All right, so we've got this thing up and running. It's cranking at 10 terahash. It is cranking at expected hash rate. Still going strong. So we'll get her cleaned up. I gotta swap out this 15-amp fuse holder. So we'll get that taken care of real quick, and then we can go from there. That was positive. I'm glad we were able to get all those caps changed out. And the board up and running, that's a good thing. Those are some big chips, man, I'll tell you what. All right, wipe that thermal paste off real quick. And then when I go to reassemble this up with the customer's heatsink on it. And then I'll burn it in for probably a half hour to an hour, maybe even overnight. I want to make sure that it stays up and running, especially after it came in for the blown up caps on the input side. Get that cleaned up real good here in a minute. All right, so our next course of action here is we need to replace the fuse holder. And I've had a couple people recently ask me how I do these. And the only reason I'm replacing it is because it got slightly melted, and I just, cosmetically, I'm not a fan. I don't like having melted connectors or melted plastics on here if I can avoid it. Just to help reduce the temperature and effort I need to swap this. So let's do that real quick. So I'll heat this up. But this is a lower temperature, and when blended with this other stuff, with the stuff that comes on the board, helps reduce that temperature down, which ultimately will help me drop this out without too much trouble. Yeah, see? You can get this. This is also a low temperature solder here. This will blend in here and reduce the temperature of all of the solder in here. Don't care about it bridging. I would almost venture to think that this mixes up here good enough. I'll be able to drop it out. Oh, she's starting to move. I'm going to push it all the way out. And she's out. Perfect. Now I just need to get another one, and then we'll get it put back in. I'll be right back. All right, we're back. I've got the new fuse holder. Now it's time to clean out these holes. So I've got this nifty tool from Hacko. It's a Hacko FR301. This is a solder sucking tool with a heated tip. So it helps make some of this easier. I might have to still heat this up a little bit with the hot air station. Yeah, it's going to be a pretty dense board. Oh, cleared that one right out. This comes in real handy when you're having to do certain header pins, but I may still need to heat the board up some more. Got that one cleared. There we go. That's looking good. The lower melt solder definitely helps this process. You can get some real low melt solder that's really, really low. I may have to, let's get this little heat. Help this thing. There we go. Cleared. Front and back look good. I'm very pleased with that. There's the front side. Looks good. Let's let this thing cool off. Cool. Now we should be able to slide that in there, like so. And then what I'm going to do is I'm going to use some Capcon tape to hold this into position, flip it over, and solder the 4 legs. That's just going to help hold it where I want it. So I can get those tacked on. Okay. All right, a little regular solder, another Weller solder product. Now these planes are very thick, so I'll come back and hit this with a hot air. Because I definitely want good solder joints here. You can see how thick that is. Just does not, my soldering iron set at 450 and it's trying to compensate right now. This board's just sucking the heat up. Awesome. Give it a little bit of flux, because you know I love using flux. Hit it with some hot air. And then I'm going to come back with my soldering iron here. There we go, that looks much better. Good, I'm happy with that. Perfect. All right. And we'll get a nice new fuse holder in place. Awesome. I also, as you can see here, I actually pulled the old fan headers off the plastic. Sometimes you can pull them directly off, and what I'll do is I will put new plastic on, 3 new plastic fan headers. This little trick saves some time. And I just pull the pins out of these. But I use a plastic tool to push them back on so that I don't damage anything on the board. Okay, so then on here, I'll show you how I do this. Then I line these up, these pins on. Push the fan header on. And I've got a plastic tool, like a spudger tool. Kind of hard to tell. And then I come in like this, right at the base of these, rock it back and forth, straight down, and it's on. It's perfect. Didn't have to go through and heat up the board again and replace those when I can just change out the plastic pieces. And like I said, I just pull the pins out, the 4 pins out of these, and do it this way. You definitely have got to be careful when you're changing these fan headers out, because if you're not quite hot enough and you pull on it, especially on the plus boards, there is a trace at the top that can be pulled with the pin. It's not held very strong around the ring. So I always prefer to do this method first if I can. You know, otherwise, the way I do it is I put them on the hot plate, heat the board up to 400°C, and then I slide this board just off the edge of the plate, and I heat from underneath, from the underside. I would heat from basically here with my hot air until it was completely liquid, and I use a pair of tweezers from the top side and just slightly pull, just very lightly. And as soon as it's hot enough and it's melted enough, it'll just lift right out. So it just takes a lot more time than this, and if I don't have to change them, I can just change the plastic out, then that is a quicker method. And these really weren't even that bad, but they did show some signs of melting because these fan headers are not temperature tolerant. You cannot run these through a reflow oven. So these are basically hand placed after a board's manufactured. Like I said earlier, they don't all pull right off. She looks good. Looks real good. Okay, let's finish getting this thing cleaned up. I'll get it reassembled. I'll come back to you guys when I've got the full thing reassembled and cleaned. Show you how it looks. Give it a test again, and then rock and roll. All right, she's all reassembled. I've put the customer's heatsink on it. I just have a temporary fan on it right now because they didn't send me their fan, just their heatsink. But you can see how nice and clean. We got it. Looks really good. Pretty happy with it. I'm going to let it hash. Probably for the next 10 to 20 minutes minimum. I want to make sure that we don't have any other issues with it. Again, I appreciate you guys tuning in. If you guys need repairs, ixtech.xyz at the very top, click on repairs, fill out the form. If you're cool, you're going to put some funny notes on the inside of the box like this last customer did. I thought that was really cool. I appreciate that. We are getting sometimes pretty backlogged. You see everything we have here. These are all evaluations that are done, that are quotes out to customers. I've already started getting approvals in. I've just got a whole line. I got 7 or 8 of them right here in front of me. Some customers send in multiple miners. So obviously response times may take a little bit longer. I would say evaluations are moving right now by about a week and a half. And then if you approve it, the repair queue is about another week, roughly. And again, this is August 22nd. So it really just depends on what I have, what the load is. Make sure when you guys, I've stressed this before in other videos, make sure if you send them in that print out your packing slip and put it inside the box, because a lot of USPS shipping labels, FedEx, other companies, we don't have a return address name. So when I get the box, I'll look at the box, I'm checking it against the open orders that we have, because we keep that repair order open in the system, identify it that way. I print out the packing slip, but if the name's not on there, or even you can even write the order number on the side of the box. I don't care. It doesn't matter. Just make sure at minimum I've got some way to identify who it's from. So I always tell customers, print out the packing slip, put it in the box. When I open it up, I can see it, then I know who it is. I do not want somebody sending me a miner and I cannot identify it, and then 2-3 weeks later they're like, hey, what's going on? I have no idea I have no idea who you are. I don't know what this miner is, you know, that you're looking for. I've got an extra one. Is this yours? Maybe, you know. So please make sure that you guys are filling that out. Another tip and trick, pay attention to your email. Keep an eye on junk mail, because I will email to you once I have the evaluation done. I will email you and let you know what's going on. Depending on the mail client you have, our email may go to your junk mail. So just keep an eye on it. We see that, I say quite often, probably 30% of our emails somehow end up in people's junk mail. So then they're reaching out to us like, hey, what's going on? I'm like, oh, I sent this email. Here's a copy of it. And yeah, long story short, just remember the email that you provide on the form is how I'm going to communicate with you. And it's going to come from me. It's going to come from repairs@ixtech.xyz. So just make sure that you're paying attention to that and looking for that email. Again, there's affiliate links at the bottom in the description below this video that are tied to a lot of the tools that you saw me use in today's repair. We do get a commission from those affiliate links, so I'm just being fully transparent. But it doesn't cost you anything else. So if you click on an affiliate link and do some other shopping, it's no impact to your pricing whatsoever. Amazon just gives us we'll call it a kickback for sending customers their way. Again, most of the stuff, and being completely transparent, most of the stuff that we use, I buy through Amazon because I'm a Prime member. I get free shipping, lots of reasons, availability. So again, if you click on those links and you make a purchase, it helps us out a lot, and we really appreciate it. But again, another customer that's going to be happy that his Nexus is up and running, hashing away, back up and running. I showed you at the beginning of the video a second customer that had sent his Nexus in that had a similar problem, but he's able to get an RMA. He had multiple cracked chips, or at least one cracked chip on his board, and several of these same caps were blown. So he was still within his RMA time period, so we're sending it back over to him so he can RMA it to the seller and get a replacement. Not sure exactly what's causing it. I talked about in the first video, maybe maybe a low quality cap, maybe a solder issue, maybe there's another issue on the board. I'm not positive. I don't know. I'm not sure. But when I replace these caps on these devices, I try to use the best that I can get my hands on, just so that we have the best possible chance of not having a repeat failure. Yeah. Again, I appreciate you guys all watching the videos. Our subscriber growth is amazing. We really appreciate it. We're going to try and do a live here again real soon. I'm trying to get out from underneath this. I unfortunately had to have surgery about a week ago, and then I had a couple days off. I had to travel to take care of some family business. So the backlog is real. So I am going to be diligently working through trying to get it all finished up and shipped back out to you guys. So again, please comment, like, subscribe, share it with your friends. If you need anything, hit us up. We make lots of accessories for all of these different miners. Appreciate you watching the video, and we'll see you in the next one.